Alright guys, this is unit number 9, lesson 3, and we're talking about square root functions and shifting them. And today we'll start you off with another little joke here. So, what are a teacher's 2 favorite words? See if you could figure that out, and I'll let you know at the end of the lesson. Alright, so we're talking about functions. Hopefully you remember what those were. Function, remember, just says that for each input value, you get exactly one output value. So, square roots are operations on numbers that give exactly one output for each given input, so they fit nicely into our definition of a function. And we could graph the general square root function once we establish a very important fact about square roots. And it starts with this here. So consider the square root of -4. Why are neither 2 nor -2 the correct square roots of -4? So think about that. Is 2 the square root of -4? Is -2 the square root of -4? Well, you should know that 2 times 2 is positive 4, and -2 times -2 is positive 4. And remember, the whole concept of a square root is that you have to have the same number being multiplied, but the only way to get a negative number is to have a negative times a positive. So this basically is an impossible task right here. And that's kind of what we're going to bring up in this part B. What can you conclude? So here we go. The square root of a negative number cannot be any type of real number. I'll stop doing that. Real number, due to the fact that squaring a real number always gives us a positive or a 0. All right, hit pause and write some of that in if you need to. And this is absolutely critical that you understand deep down inside. You got to get it that we cannot find the square root of a negative number. It's impossible. So just remember that. All right, with any real number. I'll bring that up. All right, so here we go. We have our first square root function. Okay? You got your input values, your output values. What we want to do is create or fill in the table, or create your table if it's not there for you. Create a table of values for input values of x, which you can find a rational square root. So I'll give you a hint. Like, don't use 2 as an input, because if I input 2, I can't take the square root of 2. It would be irrational. And see if you can come up with the smallest possible input value. So what is the smallest element of the domain? And then go through there. So try to fill out that table. See if you can do that now. Okay, did anybody actually use their graphing calculator? You could, but hopefully you came up with something like this. So 0 is the smallest number you can take a square root of, because we can't take any negative numbers. We just said that. So you can't have any negative numbers in the domain. So 0, we can take the square root of 0, take the square root of 1, and then the next number is 4 and 9. So all these are perfect squares. And then there is their squares here. So you should be able to graph this function pretty easy. So hit pause and do that now. Alright, so your graph should look something like that. Remember that these things are not linear, so you shouldn't make them. When you see that you're graphing something and it's not in a straight line, you should try to make curves through it. Alright, so that's what a square root function looks like. And see if you come up with the domain and the range. Could you write it out correctly? So what is the domain and range of this function here? And we do have an arrow at the end there, so let's see if that helps. So hit pause and try to do C and D. Alright, remember the domain is the x values. So if you think about it, remember, it can never be negative, so we'll never have anything on this side. So the domain would be 0 and to infinity. So it would look either way like this. X would be greater than or equal to 0, or right in set notation. And look at the range. Well, if you're not going to have negative numbers here, you're not going to have negative numbers down here. So it's pretty much the same thing. It's going to keep going up and up and up. So exact same. Alright, and this should be kind of easy. Circle the correct choice below. So, is this function always decreasing or always increasing? That's kind of easy. Hopefully you got always increasing. And last question. What shape does the square root function graph appear to be half of? This is not a coincidence. Well, if you look at it, and if we were to, I should have done a cool thing where I could just reproduce it automatically, but there we go. So you can see that kind of looks like, well, hopefully you recognize that as a parabola, sideways one. And we'll get into that, well, you'll get into it when you get to Algebra 2. So, and the reason why is because think about what the quadratic are, the parabolas, at, ax squared plus some, I don't know, 3x, but the big thing is there's an x squared, and that has a relationship with the square root, so that's kind of why they're in like that. Alright, fill that in if you need to. Moving on. Okay, so now we're going to look into shifting them. Just like we could take a quadratic that started, at the zero, what we call the parent one that just kind of started here, and then we are able to take it and shift it based on how the vertex form looked. Same concept is going to happen with these. Get rid of this. So on the graph, you have the parent graph of the square root function. So this is, nothing's happened to it. Using your calculator, graph the function, this one here, and make sure you enter it correctly. Be careful that the 4 is under the square root and the 2 is outside of it. Come up with a table of values that you could actually graph. Start with the smallest domain you could find and come up with at least, 4 input values. So do that now, please. Alright, so using your graphing calculator, hopefully you got some type of table like this. And if you think about it, it makes sense that -4 is the smallest number we could use. I know we can't take square roots of negative numbers, but think about we're putting -4 in for this x right here, and -4 plus the 4's in there. You do that math first, which would get 0. Square root of 0 is 0, plus 2, there you go. We couldn't put -5 in here, because if I put anything big or smaller than -4, you would get a negative number inside here, which we can't have. So this is the smallest possible input value. And then if I put -3, that would produce 1 in there, which is a square root. You put 0 in there, that would produce 4, which is a perfect square. And if you put 5 in there, that would make 9. We don't want to put 1 or 2 or 3 because that would make this irrational. You could do it, but it will just get you decimals. So they're looking for ones that give you nice rational output values. Alright, you should be able to graph that, and you should be able to state the domain and range. You should be able to state it just by the table, but if you need to graph it first, go ahead and do that. Okay, so the graph kind of looks like this. And therefore, if you look at the domain, remember that's your x values. The smallest one it could be is -4, and then it can be, we can have like -2 and -1. It just gets decimals, meaning that's when it kind of falls in between points like that. So those numbers are included, just harder to graph. And the range, think about the range. Well, what is the smallest possible y value? Well, you can see it right here, and then it just goes up, so here. And if you look when we did our shifts, remember that, look, this is just like the quadratic we did it. Inside the parentheses, this is opposite. It went -4, but +2. So exactly the kind of the same thing. Let's do that one more time. So now you try to graph this one, come up with a table, then graph it, and then state the domain and range for this function here. So hit pause. Do that all on your own now, please. Alright, were you able to come up with a good table for this that had nice rational output values? And again, you should think about, remember we can't have negative, so what's the smallest number we could put in for x? That would be 1. So I put in 0 in there, it would be 0 minus 1, I'd end up with a -1 in here. So when you put your input values in, the result under the square root should not be a negative. We're trying to make it 0, so 1 minus 1, then I get square root with that. So here's your values. Well, what's the domain? Well, I just told you, obviously, that the smallest value you could do is 1. You can't put anything lower than 1, so that would be our domain. And think about your range is just look at the smallest y value and go above that. And the graph, well, could you predict what the graph looked like just with this? So using the parent graph here, we could say, well, this is going to shift right 1, down 4, and then it should make some curve down here. And hopefully that's what you came up with. So there's the other graph. Alright, hopefully we're doing okay with that. So it looks like our shifting pattern that we saw with quadratics holds with square root functions. This pattern, in fact, holds no matter what function we're looking at. So if we look at other functions, this type of shifting happens all the time. For example, let's look back at our good friend, the absolute value function. You probably forgot about that. Not very good friend. Alright, so here is an absolute value function. You can see you input the x, get out the y. So on the graph to the right over here, this is again the parent function, meaning the most generic function you can have for the absolute value. Use your calculator to create a graph for this one. You should know how to input the absolute value in the calculator we did show you. You could quickly look it up online, you're smart people. And then come up with a good table, something that you could actually graph. So you come up with your own values for the input and output using your calculator, and only include your table for things that you could fit on the graph. Then you're going to go ahead and state the domain and range, and then do it again down here. So I want you to do this whole thing because it's really too hard for me to just do it in pieces. So I want you to do all A, B, and C on your own, and then only hit play once you've done them all. So do that now, please. Alright, so did you come up with a table something like this? You might not put as many values as I did, but remember, absolute value is kind of, in a sense, like the quadratic. You got this turning point, and then look, you have exact pairs on the opposite side, because like this, absolute value of -6 is the same thing as +6. It's a little different when you start moving things around here. And were you able to come up with the domain and range? It might help if we actually look at the graph. Now the graph's going to come up with both. I couldn't kind of hide them, so we'll just deal with it. And we labeled it at least. So here is that one, and there's the graph. And you can see it did what it's supposed to. It shifted to the left 3, down 2. So it looks like the domain could be any numbers, because I could just keep going this way and keep going that way along the x. But on the y, we do have a minimum value. So domain is going to be all numbers, and then you could say that all real numbers, or it goes from -infinity to +infinity. But the range does have a minimum value, and it would look something like that. And then you were supposed to come up with this function down here, and if you were able to read the shifts, okay, that would be right 2, down 1, which exactly happened, right 2, down 1. And again, the domain is all numbers because it just keeps going along the x-axis, but along the y-axis there is a minimum value here. So I don't think they asked you to put the domain and range. Nope. And I believe that is it. So it's time to answer our riddle. What are our teacher's 2 favorite words? They are July and August. Ha! Yeah, because then we don't have to see you anymore. All right, we'll see you in class tomorrow.